Greetings Calculus under quarantine, first ever video lesson. So before the closure, I told you that the integrals we were doing were probably the toughest ones we were going to do for the year, and that's certainly going to hold true. What we're going to be doing now going forward is going to be, the integration part's going to be a lot easier. There's going to be a little bit more geometry involved, a little bit more algebra involved, there's going to be graphing involved. So what we're after now with this lesson, which will take us about a week, is finding the area between two curves using calculus. So what we're going to be looking at is, you may recall back in January or early February when we learned about integration, we said that if you take a curve, what an integral does is finds the area under that curve. And you learned that this very accurate process, where we remember how we sliced that up a whole bunch of times, and there was a limit with a sum and all that happy stuff, which we don't really need to worry about right now because we already learned it. But basically what you learned was that that's the integral of that function f of x dx. Okay, so what we're going to change now is we're going to put a second curve on there, and what we're going to be worried about is how to find the area directly between these two curves. Extremely accurate using calculus. So what we're going to do is we're still going to maintain this A and B, so the intersections here are going to be the boundary values. Okay, so we're going to do an integral from A to B, moving left to right. A is further on the left, B is on the right. So this is the right side boundary, and A is your left side boundary. When you draw this curve, this top curve, we'll call that f of x, and this other curve, we'll call it g of x. So basically what we're going to do is do the top, subtract the bottom, so it's f of x minus g of x. And of course, the differential has to be added on there, dx. So this is kind of the process right here that you need to understand. That when we're going between two different curves, it's from left to right, top minus bottom. So f of x minus g of x. Now sometimes the tricky part is figuring out which one's on the top. Fortunately for you, you have your inspires. Okay? Today I'm going to take you through this algebraically with just a little bit of help from the inspires. Later this week, in a day or two, probably Wednesday or Thursday, I'm going to show you how you can do this totally on your inspires, but I don't want you to use that as a crutch. I want you to use the inspire as a tool, because next week what we're going to do is we're going to take this process and we're going to calculate volume by rotating a region around an axis. And when we do that coming up next, your inspire does not do that. So take this as a little bit of caution. You can use the inspires, and I'm gonna post a link to where you can see on YouTube how to use the inspires to do this, and we'll talk about it in our meeting later this week. But if all you do is put everything in the inspire and have the inspire get the answer, you're not going to know how to do anything. Especially when we move on to volume, you're going to be completely lost. So what we're going to do is go through a simple problem today. Actually, we're going to go through more than one problem today. So let's look at a problem, and we'll try to clear up any questions you may have. We're actually going to do a few problems today, and we'll finish with one that involves a little bit of symmetry, which sometimes makes our lives a little bit easier. So I'll be right back on camera here in a second. So we're going to find the area. We're going to find the area bounded by, let's see, where's my problem at here? the function y equals x squared and y equals 2x minus x squared. Okay, so what does this look like? The very first thing you want to do with these problems is get a picture. Without a picture, you're not really going to, first of all, you're not going to know which one's on top, which one's on the bottom. Secondly, without getting the points of intersection, you're not going to have the bounds. So here comes Algebra 1, Algebra 2 zooming into the picture that you have to know how to do. Now, fortunately, the Inspire is going to do this for you. So let's make our picture over here. We all know what y equals x squared is going to look like. We've seen that a million times. We all know that that's a basic parabola. Okay. If those of you that might remember, 2x minus x squared means it's a parabola going down where it's gonna shed water. So it's gonna kind of look like this. Okay. All right, so how do we know these points of intersection? Well, if you graph this on your Inspire, which again, when we go through the meet, if you have any Inspire questions, we can take care of them. But if you graph this on the Inspire, this is the area that we're after. And if you look at that area, that doesn't even remotely resemble any of the area formulas that we did in geometry. So this, finding area is a big deal in calculus. And here's a really weird shape, but we can find the area extremely accurately for. So a lot of you are probably looking, well, I know that point of intersection. Yeah, that's the origin. So there's 0. 0, 0 is right there. Okay, so how do I find that other one? Well, the Inspire will do it for you. The Inspire has a function when you go in there. The Inspire has a function where it'll find the intersection. I'm going to kind of leave that for a kind of a separate video. I'll post how to do that, and we'll take care of it in our class meeting. But if you're going to look at this algebraically, how do you find where these two things meet? You set them equal to each other. X squared equals 2x minus x squared. This is the old school way. This is the way you probably learned it in Algebra 1, Algebra 2, because it's a system of equations, which I know you did during those 2 years. Okay, so we're going to take everything to one side here. So I'm going to take everything over here. So when I bring everything over here, I'm going to get 2x squared minus 2x equals 0. So I just got everything moved to the left. Our good friend factoring is going to show up. We're going to do 2x times x minus 1. Solve. There's our 0 that we already said we had. There's the 0 right there. And then look at, there's x equals 1. So guess what? That's this point right here. So that this value here is 1. So this is going to be 1 comma something. And we don't care about that something. In these problems, we only care about the x values. The y coordinate for right now does not matter for anything. We're not going to do it. Don't worry, we're not going to come back to it today. So all we care about is that that's 1. So we have 0 and 1. So we can start constructing our integral now. So our integral is going to go from 0 to 1. So now you have to look at that picture. Which is the top function, which is the bottom function? Well, remember, it's left to right, top minus bottom. So the top function is this upside down parabola, 2x minus x squared. So 2x minus x squared, there's the top, minus the bottom, minus the bottom function was just our everyday parabola, x squared, and there's our differential. So here's left to right. So that's the format that I had on before I erased the board that I had on the previous slide. So from here on out, this actually, folks, the hard part in these problems for most students over the last however many years I've been doing this, the hard part is all of that. That's usually where kids make a mistake. But you have the Inspire now. So I would probably expect the Inspire can do all of this. And we'll take care of that again, like I said earlier, we'll take care of that moving forward. Alright, so the Inspire won't take care of this. It'll give you this area, but getting all this work, which is what you're going to have to do when we go to volume. So I already kind of talked about that. So let's simplify this. 2x minus 2x squared. Okay. Now some of you might be seeing, hey, there's a 2 there and there's a 2 there. And what Scannon said a long time ago, we can always pop a constant out front. We can. We can do it that way. So if you want to, that 2 can factor and go out front. But I'm going to kind of just leave it there because I know sometimes that stuff confuses some of you. So take the integral. There's 2x. So what do? We add 1 to the, and we divide, right? So that's going to be 2x squared divided by 2 minus 2x cubed divided by 3. Evaluate from 0 to 1. So these 2's cancel right here. Just a little bit of a simplify. Again, evaluating from 0 to 1. So I know everybody can get to that point. All the rest is plug and chug. And if you're looking at that, you're saying to yourself, oh, I like plugging in a 0 because zeros are awesome to plug in because guess what? That 0 is not going to do anything. Plug in a 1. So we got 1 squared minus 2 times 1 cubed over 3. So we have 1 minus, it looks like 2/3, which is going to be an area of 1/3. Okay, an area of 1/3. So the area of this little sliver, okay, the area of that little sliver is 1/3. If you get a negative, area can't be negative. Think that through. Area can't be negative, just like distance can't be negative. Volume can't be negative. These are real, actual measurements. So area can't be negative. If you get a negative here, 99% chance you have the top and the bottom messed up, and they're backwards. Probably a 1% chance that you have these numbers met, the left and the right are backwards. But usually, 99% of the time, people have these 2 messed up. And you'll end up with kind of the same thing here, but it'll be negative. So that's just a good little trick for you. So you might be wondering, you know, what the heck is this used for? Why would I want to know? Well, look at that shape. Look at that sideways. Look at that shape. If you kind of look at this shape, you know, that kind of probably looks like a fish, sort of, maybe like a torpedo. But if you look at a shape like that, you know, that shape is like kind of like the cross section of a plane's wing. It's also like kind of looks like the gas tank on some motorcycles. So a lot of these weird shapes, engineers use this stuff to figure out the areas, and more importantly, coming up in another week or so, the volumes of these shapes. So that's kind of where a lot of this stuff is used, for these odd looking shapes that they're, you know, think about it. You can't apply pi r squared. You can't do any of the trapezoid formulas or any other formulas we learned in geometry. They were basic polygon formulas or circles. You can't do that here. These are really weird shapes. And going forward, you're going to see a lot of shapes that are even stranger looking. Okay, so let's do another one. And we'll start this over. Let's do another shape. So we're going to find the area. Is the green coming through on camera okay? Mm-hmm. All right. Find the area between y equals x and y equals x squared minus 6. Okay? So again, a pretty straightforward problem. Let's make a sketch over here. All right, what does y equals x look like? Well, I hope you're thinking about what these things look like, because this one's a pretty easy one. you're gonna end up going to your Inspire and typing them in and graphing them. But y equals x. Y equals x is your 45-degree line, right? You probably learned that in 8th grade. Y equals x squared minus 6. Well, geez, positive x squared, that's a parabola opening up to collect water. Minus 6 means it's shifted down. How far down? Guess what? 6. So 1, 2, 3, 4, 5, 6. Right here. Draw your parabola. There it is. What am I looking for? Look at that shape. That's a really strange shape. And we still kind of have that teardrop kind of a shape. That's because we're dealing with a parabola. They all won't have parabolas. They all won't have a parabola in them. But for right now, these are easy. These are really simple functions for us to examine. So what's the most important thing? Well, if we're going to start making our integral, the top function of the shaded region is x. Boom. This is the top. Top minus the bottom. The bottom function is x squared minus 6. Don't forget, right here, that parenthesis, because of this negative, you have to distribute the negative through that parenthesis. We'll see that as soon as we get going. What are we missing before we can do this? We need our boundaries of integration. We have to find this value, specifically whatever this number is, and over here we got to find that value, specifically whatever that number is. How do we do that? Again, the Inspire will do it for us. We're going to do it algebraically today. Set them equal to each other. X equals x squared minus 6. Get everything on one side. 0 equals x squared minus x minus 6. Ooh! Hey, it looks like we can factor again. Remember that? Because factoring in quarantine is fun. X, multiples of 6, let's see, how about minus 3 plus 2, and when I solve, right, I'm going to get 0 equals x minus 3, and I'm going to get 0 equals x plus 2, which means my values are positive 3 and negative 2. Those are the x coordinates, see, because it says x. So guess what? This one, this is 3, okay? There's my 3 right there, and negative 2 is over here. Those are exactly the values I was looking for, okay? Those were exactly the values I was looking for. So let's plug them in on our integral. Remember, we're going left to right, so the bottom one has to be smaller. If it's not, your answer is going to be jacked up later. And remember, top minus bottom, if you get that backwards, you're probably risking getting a negative. Okay? So minus 2 up to 3. Folks, we just did all that work. That's Algebra 1 and Algebra 2 rearing its ugly head again now in calculus with 9 weeks to go before you graduate. Okay? So, let's do some calculus now. First, I got to simplify. What do I have to do first? Take that negative through. X minus x squared, negative times a negative, positive 6. See those arrows I was cautioning you about? I'm going to connect them right there because those are the places. Boom, plus 6. I know some of you are going to want to put a minus 6 there, especially the girls on the left side of the room. I know you're going to want to put a minus there. Be careful. Okay? All right. So let's take the integral now. X squared over 2 minus x cubed over 3 plus 6x, evaluate from negative 2 to 3. We're not blessed with plugging in a 0 now, so we have to do a little bit of extra work. All right? But look at that integral. That integral, a lot easier than those U substitution ones that we were doing last week and we were doing last month right before the closure of school. A lot easier. The integrals here are a lot simpler. They tend to be very, very basic. Okay? So, Let's plug in. Remember, we're going to plug in the top. It's going to be top minus bottom again. Top minus bottom, just like up there. So plug in the 3 squared is 9, so we get 9 halves. Minus 3 cubed is 27. 27 over 3 is a whole 9. 6 times 3, 18. Wrap it up in a parenthesis. Boom. Over here, negative 2. Be careful of the negative. Negative 2 squared is 4. 4 over 2 is 2. Minus, be careful of that negative, minus 2 cubed is minus 8. That's going to make this plus 8 thirds. 6 times negative 2 minus 12. So I'll give you a second, because I'm sure a lot of you are going to be stopping and doing some of this work on your own. Let's see, this is 18 minus 9, so this is just 9 halves plus 9. Well, let's see, 9 halves, that's 4 1/2.